Hello, everyone. In this episode, we are going to dive into the core of traditional logic, and that is categorical syllogisms. These are the basis of deductive reasoning, and to begin, we need to learn about the structure of syllogisms. Syllogisms contain exactly three categorical functions, containing exactly three terms. Anything more, anything less than this will lead to fallacies. I'm sorry, I am getting over a cold, so my voice is pretty weak, but I have some water with me and I'm going to try to make it through this video. Categorical syllogisms consist of 1. A major premise, 2. A minor premise, and 3. A conclusion. So, take for example this syllogism. The major premise is all mammals are warm-blooded. The minor premise is all dogs are mammals, and the conclusion is all dogs are warm-blooded. As you can see, two premises lead to a conclusion because it was correctly structured. As I said before, every syllogism contains three distinct terms. The major term is always the predicate of the conclusion. The minor term is the subject of the conclusion, and the middle term is present in both premises, and it essentially acts as a bridge linking the major and minor terms. As a note, the major term is often denoted as P, the minor term is denoted as S, and the middle term is denoted as M. So if you see those labeled on sentences, that's what this is talking about. Going back to the previous example, the major term was warm-blooded, the minor term was dogs, and the middle term was mammals. If we have more than three terms, this actually leads to the fallacy of equivocation or the fallacy of four terms. We want to avoid that. Now we can move on to discussing the mood and figure of a syllogism. The mood of a syllogism is the arrangement of A, E, I, and O statements in the premises and the conclusion. We discussed those four statements in the last video. Sorry. So again, syllogism follows the pattern, the major, minor, and then conclusion. If it follows that pattern, the mood is said to be AAA. The figure of a syllogism depends on the position of the middle term in the two premises. So there are four possible figures. Figure 1 is MPSM, meaning it goes middle term, major term in the first premise, and then minor term, middle term in the second premise. That's figure 1, that's the arrangement of figure 1. Figure 2 goes PMSM. Figure 3 goes MPMS. And figure 4 goes PMMS. So we can identify a syllogism's identity as a combination of its mood and its figure. So we can say a syllogism could be AAA1 or A002. It's worth noting that some combinations are valid and some are invalid. Just because the identity exists doesn't mean that the syllogism is valid. Speaking of the validity of syllogisms, there are 6 rules that determine whether a syllogism is valid. A syllogism is only valid if it satisfies all of these rules, follows all of these rules. The first being, as we said earlier, it can only contain 3 terms. And a single term cannot be used in more than one sense. Rule 2, the middle term must be distributed at least once. If the middle term is never used universally, the premises never actually connect S and P. And therefore, you can't draw a conclusion. The third rule is if a term is distributed in the conclusion, it must be distributed in the premises. Basically, you can't make a broader claim in the conclusion than you did in the premises. Rule 4 is that the syllogism cannot have 2 negative premises. You may have heard this in real life, but 2 denials cannot imply an affirmation. Rule 5, if one premise is negative, the conclusion must be negative. You can remember it this way: negativity propagates downward. And finally, rule 6 is that no conclusion may be drawn from 2 particular premises. As you may recall, particular premises are some or some not. You cannot draw a conclusion from 2 particular premises. Now we can move on to classical syllogistic fallacies. Each of these rules that we just discussed, if you break one of them, it yields a specific fallacy. If you violate the first rule, that is a fallacy of 4 terms, although it could really be any number of terms. This is essentially when ambiguous language, it introduces extra meanings and you can't draw a conclusion. Violation of Rule 2, as you may suspect, this is the fallacy of the undistributed middle. This is probably the most common error in invalid arguments. The violation of Rule 3 leads to an illicit major or illicit minor. This is essentially when a conclusion distributes a term that was undistributed in the premises. It's exactly what Rule 3 forbids. A violation of Rule 4 is called an exclusive premise. Again, 2 negative premises cannot yield a conclusion. Violation of Rule 5 is drawing an affirmative conclusion from a negative premise. Essentially, if you deny, you must conclude with denial. And finally, violation of Rule 6 is existential fallacy. Again, 2 particular premises cannot provide a conclusion. Now, how do you test a syllogism for validity? When you're given a syllogism, you can go through these 6 steps and it will tell you if it is valid when you get to the end. The first thing you want to do is identify the major, minor, and middle terms. You can mark them with the S, M, and P that I was telling you about earlier. I'm sorry. The second step is to rewrite the premises and conclusion in standard form. This is something we discussed in the previous video. The third step is to label each proposition as an A, E, I, or O statement. This was also discussed in the previous video. The fourth step is to determine the figure by noting the position of the middle term. It's either 1, 2, 3, or 4. The fifth step is to apply the 6 rules. And finally, the 6th step is to conclude validity or identify the specific fallacy. let's practice, because I know this was a lot to go over all at once. We have the syllogism. I'm going to read the 3 lines. All philosophers are thinkers. Some artists are not philosophers. Therefore, some artists are not thinkers. Okay. Let's begin with the first step, identifying the terms. The major term here would be thinkers. The minor term would be artists. And the middle term would be philosophers. What about the premises? The first premise is an A statement. It's a universal affirmative. The second premise would be an O, particular negative. And the conclusion is also an O statement, particular negative. Now so we could say it's an AOO syllogism. But let's go through the rules. One immediately stands out to us. We've broken the one of the undistributed middle. The middle term only appears in the first premise. It's not distributed in the second. This is a fallacy of the undistributed middle. Also, the conclusion distributes P, the term not thinkers, but P is undistributed in the previous premise. This is a fallacy of an illicit major. So this argument is invalid. Now that we've covered the essence of categorical syllogisms, we can now start learning about them in incomplete and or compressed forms. We can still use syllogisms even if we don't see them in the exact form that we just talked about, because classical logic teaches us that we can use conditional reasoning to understand syllogisms. I know that sounded kind of abstract and maybe I didn't explain it very well, but I'm just going to leap right into the form of a conditional proposition. It essentially goes like this. If A, then B. It's that simple. So take this example. If something is human, then it is mortal. If A, then B. It's the idea of a syllogism that's there. Now, we still have to be careful about fallacies, but I will admit in this simple structure, it's harder to make a mistake. In classical logic, conditional arguments are evaluated according to whether the antecedent or consequent is affirmed or denied. So 2 valid forms are recognized. The first is modus ponens. That's the Latin. This is the first form. It's if A, then B, A, therefore B. The second form is modus tollens. If A, then B, not B, therefore A. I'm sorry. Well, I misread that. It's if A, then B, not B, therefore not A. I'm very sorry about that. Invalid forms, like the one I just uttered, occur when one affirms the consequent or denies the antecedent. These errors appear intriguing or persuasive, but they fail logically, and that's why it's important to understand the fallacies we just discussed when we were doing categorical syllogisms. Conditional reasoning is often undergirded by syllogistic arguments, and they have to be extracted as we analyze them. This is something we'll discuss more as we learn about enthymemes. Enthymemes are basically imperfect syllogisms. They're arguments in which one premise is omitted because it's assumed to be obvious or it's commonly accepted. Take, for example, the sentence, Socrates is mortal because he is human. The major premise, all humans are mortal, is pretty much accepted. It's implied. It's not stated, however. Enthymemes are extremely common in everyday language and even in higher forms of writing, like rhetoric, law. The task of logic is to restore the missing premise because it is an imperfect argument. You should state all of your premises, even if it seems a little bit redundant or silly. Sorry, I'm sorry if this is loud. I'll take the mic away from my mouth when I cough. An argument that appears persuasive may fail once its hidden premise is made explicit, which is why teachers of logic always beg their students to state all of their premises. Now we can consider polysyllogisms. A polysyllogism is a chain of syllogisms where the conclusion of one syllogism becomes the premise of the next. Let's take this example. All humans are mortal. All Greeks are human. Therefore, all Greeks are mortal. All Athenians are Greek. Therefore, all Athenians are mortal. This polysyllogisms are really the most real world logic that you get. This is what we do every day. We leap from one premise to another. We draw conclusions. We draw new conclusions from previous conclusions. This is what scientists do. This is what lawyers do. This is even what I do, and I don't really have a real job. This basically undergirds all intellectual inquiry, and I guess this shows why it's so important to do logic step by step from first principles so that you can draw correct conclusions. Now we can move on to Sorites. I assume that's how you pronounce it because it is a Greek term. If I'm being honest, I've never had logic taught to me by a real person. I've just read a couple books on it, so I'm not even sure if I've been pronouncing everything correctly, but I'm just going to say Sorites. I'm sorry. A Sorites is just a compressed polysyllogism in which intermediate conclusions are not stated. For example, this would be a Sorites. All mammals are animals. All dogs are mammals. All retrievers are dogs. Therefore, all retrievers are animals. As you can see, the conclusion between those two syllogisms were not stated, and there is a danger in using Sorites because weaknesses are not immediately obvious. If any step fails, the entire chain collapses. Now that we've covered compressed syllogisms, we can now start to look at arguments that don't just assert premises, but they also justify them. An epikairema is a syllogism in which one or both premises are supported by reasons. take this as an example. The first premise of the syllogism is all beings composed of matter are corruptible because matter is subject to change. The second premise is all humans are composed of matter. The conclusion is therefore all humans are corruptible. As you can see, the first premise was justified with the phrase because matter is subject to change. It didn't have an effect on the final conclusion, but it did strengthen the syllogism because one of the premises is justified. Next, we can talk about the dilemma, which forces a conclusion regardless of which option is chosen. This is the structure of a simple dilemma. If A, then B. If C, then B. Either A or C, therefore B. This sort of stuff fascinates philosophers, Redditors, everyday people. But they are only valid if the alternatives are exhaustive and the conditionals are true. A complex dilemma produces different conclusions from different alternatives. They might be undesirable or unavoidable, but the structure I just stated was that of a simple dilemma. But now we can turn back to compound syllogisms, which combine categorical and conditional reasoning. Take the example, all humans are mortal. If something is mortal, then it can die. Therefore, all humans can die. Here, categorical logic supplies the content, but conditional logic extends it, I guess. We are coming closer to the end, but I do want to address a distinction fundamental to all science, and that is induction versus deduction. Deduction proceeds from universal principles to particular conclusions. So if the premises are true and the form is valid, the conclusion is true. Induction proceeds from particular observations to universal conclusions. Take, for example, this. It would be, this dog is brown, that dog is brown, therefore all dogs are brown. Deduction produces a large degree, or really, it does produce certainty. Induction does not. It only, at best, yields probability and a degree of, it's, I guess, natural certainty, depending on how good the syllogism is. It's sufficient for empirical science, but it's not sufficient to say this is the truth just by induction. Aristotle recognized induction as necessary for establishing first principles, but he did recognize that those principles cannot themselves be demonstrated deductively. Now we can start discussing really the peak and summit of classical logic, and that is demonstration. A demonstration is a syllogism that produces scientific knowledge. Scientific knowledge is necessary, universal, and derived from true, primary, and immediate principles. According to Aristotle, science is not merely facts, but it's a knowledge of causes. Following from this, a true demonstration proceeds from what is better known by nature to what is less known by nature. And this requires first principles, which are not demonstrated, known through intellect, or grounded in reality. These first principles include the principle of non-contradiction, the principle of identity, and the principle of sufficient reason. Demonstration differs from persuasion. Rhetoricians seek your agreement and intellectual assent. Scientists want the truth. Notably, demonstrations require that the middle term expresses a real cause. I know that was kind of a lot, and some of it was airy and kind of, misty-eyed, but here's an example of a demonstration. All planets orbit the sun because they are governed by gravitational attraction. Earth is a planet, therefore Earth orbits the sun. In this demonstration, the middle term explains why the predicate belongs to the subject. Earth orbits the sun because Earth is a planet and it is governed by gravitational attraction. Aristotle makes the distinction that knowledge is something is the case, and knowledge is why it is the case. The knowledge of something why something is the case is what science is. No, science is not just a collection of facts, it's also understanding what causes everything. So this last part was really to show that logic is not just for debating. It's the art of the mind. It's the discipline that allows us to find out the truth, and it gives us steps to do it correctly. Once you really study it and learn it and it becomes the language of your mind, I really think that you can do anything in science. Thank you for listening to these 2 videos with me, and I do hope to release a course on material logic, which would be more suited to a rhetorician because it covers more of the content of formal debates and arguments. But this course on traditional logic was very dear to my heart because science is really my favorite passion of all, and this would help any scientist to learn more about traditional logic. So I really just want to thank you for listening to these videos, and I hope you have a great time learning.